All right, so last time we were talking about planets and moons in the solar system that might have life. Not talking about intelligent life, just talking about stuff that's alive, period. And we're going to start with this question. Europa and Enceladus, both ice-covered moons out here, but have tidally warmed interiors and probably a very vast water ocean. Might these have all sorts of examples of life down there just waiting to be discovered? And we see in our own oceans, deep sea hydrothermal vents, early expectations for how life arose were like tidal pools where you had chemical and temperature gradients and water that came and went and things like that. But those are pretty hostile environments and they're quite irregular. Down here you may have thousands and tens of thousands of years of very sharp chemical and temperature gradients that are also very stable and protected. So it certainly could be a way that life could go, and without sunlight, you've got still everything you need for life. So you have a chemosynthesis to be the driver of life itself. And of course this could happen in other worlds. So as stars get older, they get hotter, and our sun is doing that. It's Brandon, you're being a little too loud. Let's keep it quiet. So one of the problems we have modeling early Earth is when we take a look at conditions back then, stay over there please. Early conditions, we see that the planet ices over very easily. And so we have to explain why and how the Earth itself became somewhat glacier-free. And we do see evidence that ice existed all the way down to the equator. But as things get warmer, the habitable zone expands outward, and the area where things are inhospitable expands outward. So Venus, probably early on, was in a much more gentle environment. So if we're going to look out into the universe and look for life, again, just simple life, head over there, buddy. Don't touch the wall. Brandon, don't touch the wall. Things we want to look for are disequilibrium chemistry. So chemistry that is mess. Brandon, you're a mess. You're being permanently recorded, so I need you to be quiet. All right, so when we see this most recently with Mars, we see both oxygen and methane signatures, and there are easily geological reasons that we would have methane and oxygen releases, but life will do that too. So what we need to do is look out there and see if we see oxygen-rich atmospheres. Ours is sustained by life. If you shut off the green stuff, then you only have like decades to a century of oxygen left before it's all gone. So looking out into the 25 nearest stellar neighbors, we have just a few. There's not many out here. So there's 10 light years out to this circle here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, about 20 within 10 light years. Within 250 light years, it jumps a lot to 260,000. So we have a lot of things to look at, 100 light years out to this inner circle right here. Still, as we're going to get to communication channels, light is slow. And even getting communication out to anything in this realm is ridiculously long and impractical. Looking even further out, looking at the entire galaxy, we have many billions, maybe close to 1 trillion stars as candidates, but anything that we get from this distance is going to be vastly different than what it is currently. And going out to crowds of galaxies around us, that's just ridiculously far and ridiculously faint. Signals we get from any civilizations out this far are too much. So who's looking for exoplanets? Let's take a look at exoplanets, because that's what you seem to need to get life, is a nice platform for it. The Keck, Lick, Anglo-Australian Telescope, Magellan telescopes are all in the hunt. Numbers updated just today. I can see us back in 2008. No, just go sit down over here. 2008 we have under 300. 2012 or less than 800. Kepler candidates unconfirmed at this point as of yesterday are 2420. And all exoplanets plus the candidates today is just over 4,000. It's pretty good numbers. Yeah. Very first confirmed exoplanet came about in 1992. It was strongly suspected in 88, but they just didn't have a clean enough signal yet to convince the astronomical community. It is funny to think that science was so skeptical that these things are out there until we could really start getting a good catalog of them put together.
It's amazing how much blinders they have on
I know.
our own solar system.
Yeah,
There are planets.
we're crowded with planets, right? We got.
Why are we different?
And it's so much easier to make a small planet or an asteroid than it is a Jupiter-sized thing. So the numbers should be pretty outstanding for the little Earth-sized things. But until we see it, we just don't believe it. So yeah, most of the discoveries we have made are massive gas giants because they are so much easier. Yeah, they move the star for using that detective mesh. They block out a lot of sunlight if you're using transit method. Just a quick sampling of a few of these planetary systems out there. The 55 Cancri system has 5 planets that were discovered in the decade 95 to 2005. You can see that it's very comparable to our solar system. It's a dimmer, smaller star, so the habitable zone is going to be in closer, but we have a couple candidates way in there.
But the star is whiter, so it's a little hotter?
I think it's redder, yeah, it's a cooler star, yeah.
Okay.
Looking at the numbers over time, again, a lot of this is due to Kepler. We'll talk about Kepler in just a minute, and improved observation techniques. But it was slow going through the 90s, just a handful here and there. And then in the 2000s, it shoots up. Going beyond 2008, you can see 2011, kaboom, you got another survey going. 2011 is this little bump, and more recently, it's just exponential how much we're discovering. The numbers are very staggering. Now, we've lost Kepler on its primary mission because gyroscopes have failed. And so the numbers have dropped off recently, but that's about to change. A few other interesting ones. Gliese 581c, also known as Wolf 562, which I think they might have used in Star Trek, or it's a similar name. Only 20 light years away. So, I mean, 40 years. You send a message out and get a message back in that period of time, and inside of a person's lifetime, you get a couple messages. So.
The budget cycle.
Yes, that is true. You got to keep listening for a whole time period. And what if they, as we're going to see, we're going to debate whether it's a good idea to talk to other civilizations on our own planet. When a technologically advanced civilization has come across one that is less so, it's usually pretty much a rout. They kind of take over and take what they want, and that's been our history repeatedly. So is that true of other civilizations?
They're more intense, they already know about us.
That's right. They're just enjoying free cable television. Let's keep that out of here. Keep back over here, please, sir. Stay behind this big green line. See the line? Stay back over there, okay? Gliese 581c is in the constellation Libra. It's around a very cool, small M2 class star. It's half again larger than Earth, gravity about 2¼ times larger. Artist representation of the Gliese system. It's ice, if it is an icy water composition, and that would make it much closer to Earth size, maybe 1¼ times. Its year is 13 Earth days long, so it is very close to the sun and heading around. Because of this, we believe it's tidally locked, probably 1-to-1, so one side's always facing that sun.
It really revolves around the planet. It revolves around the stars.
Right.
It really goes fast.
It really does. I mean, Mercury's 88 days, so we've got 13 days for this one. Gliese 581c most likely is about this much larger than us. Here's the sun side. What you might have, if there's a lot of water here, is a permanent region of convection here where the maximum heating occurs. Subsidence in an area around here, so you'd have like deserts here. And then you'd have cold fronts intruding from the icy backside that's permanently frozen. Yeah, so it'd be an interesting place. You'd probably want to live someplace in here where the fronts aren't too strong and cold, but not where it's constantly raining and thundering if such things are happening.
There's a detectable difference in gravity on the sun or star side and the anti-star side.
Right. That's interesting, yeah.
Fast around the star. So you get centrifugal force on the outside.
Could, but you also just might have a permanent reservoir of ice building up, so disproportionately, so it might make it off center. Brandon, stay behind the line over there, please.
And ultimately, if you get too much ice built up on the outside, would it then change its phase lock? Would it rotate?
Would you, or might you just have glaciers advancing out? Stay behind the line, please.
It's kind of cool.
Oh yeah, the imagination one can put into it. And I don't see a lot of these things being explored in science fiction. They don't have interesting locations like this. In the Star Wars universe, it's a desert planet or a forest planet or a city planet. It's just everything's one biome. OGLE, or OGLE 2005, blah, blah, blah. Another near Earth-sized planet with some problems. There it is. It is 21,000 plus light years away from us, 2 to 4 astronomical units from the sun, but it's another very dim M-class star, so it is very cold. Average temperature about 370 degrees below 0 Fahrenheit. Has a 10 Earth year, so it's just lazily going around a very cool star in a very cold location. So a lot of these discoveries came from Kepler, and Kepler was an exploratory mission to kind of see, look at one small spot of the sky and see what we see, and from that we can derive.
And it had a very large focal length staring array.
Yep. In fact, we'll take a look at that right now. It's best operational. Yes, sir.
I want to walk to the zone.
Okay, after on the break, stay over there behind the line, please. So it did its best work in about the nearest 3,000 light years, but there was some data collected even further out. The area it was staring at is right up in the wing of Cygnus the Swan between Deneb and Vega. You needed a place that didn't have a lot of very bright stars, but also was kind of close to the Milky Way, so they picked that location. Here's the detail of its field, and stay back over there.
I
Look.
don't want to play with the
Okay, we'll put it down, play with your pad. Another one, Kepler 22b, is in the habitable zone with probably liquid water, if there is water in abundance there. It's again 2.5 times the diameter of the Earth. It's one of 29 confirmed habitable zone planets close to the size of Earth at the time that it was discovered. Its year is 290 Earth days long. So, and it's also a very similar star to us, yeah. So this is one of the best candidates. Turn the volume way down. And the Kepler 22 system compares to ours in this size. Kepler 22b located just about that same distance from its sun as ours, but it's big. So it's like Camino in Star Wars. Kepler 20e and 20f, very similar to Venus and Earth size. 20e is the first planet smaller than the Earth, orbiting a sun that's similar to our star. Its year is 6 days long. So the temperature on the sunny side is 1400 degrees Fahrenheit. So this is bad for the Goldilocks thing. Yeah.
There is no liquid water.
No, but its radii probably almost exactly the same as Earth. So we have other things we can study, things that, unless there are maybe a binary planet system where you have tidal forces warming things up, you do have planets drifting between stars. It seems that it's quite possible that, turn it down, Brandon, that our system probably ejected some planets or early planets in the times that Jupiter and Saturn were shifting around. We can discover these by taking a look at little gravitational twinkling of distant stars as these things wander between the stars. We have 17 such planets or candidates now. We have an Earth to Neptune size one here, Jupiter to almost brown dwarf size. Brown dwarf again is a star just about big enough to have nuclear fusion occurring in its core.
Well, you have to have really good resolution to see gravitational lensing optically around a small star.
Yep, and it only happens for a moment. It's just
Typically, we see it around a galaxy.
right. Yep. So it's just a little twinkle that we get. It definitely has to be space-based for these observations.
That's where AI comes in, I think, in analysis of the data.
Mm-hmm.
AI can spot that stuff.
Now the big call right now is getting a lot of these it's like I did my news update a couple months ago, high-resolution, large-scale surveys that are very fine in time resolution as well. When we get gravitational waves detected, we want to be able to turn it down, Brandon. Brandon, turn it down. Volume down, please. Thank you. And so we want to be able to catch the optical signature, if there is, of any of these events, things like that. Barnard's star has a planet now, as we know. Second closest star to our sun, with a stellar system that's known. It's the fourth actual star by distance. It's only 6 light years away. It's got the highest radio velocity moving across the sky. Its proper motion was detected and measured really well in 1916. It's a very small, old red dwarf. And Barnard's star B has a 232-day orbit. It's only 0.4 AU from the star, gets 2% of the sunlight that we receive, so it's extremely cold. So this comes from the Red Dot team. They also found the planet, or now planets, around Proxima Centauri that we had in our updates too. And so the Red Dot is looking at Ross 154, Proxima Centauri, Barnard star. They're trying to really focus in on these closest stars, ones that we could actually communicate with or send probes out to. Barnard star is right down here, and it's in the Serpent, isn't it? Serpent's Cardia, right off of Ophiuchus.
Yeah.
And there's 1991 to 2007. It's positioned throughout that time frame. So it's cooking.
Pretty noticeable.
I've never looked at it in my telescope. I've never tried to find Barnard star. I don't think it's particularly dim. I think it's probably pretty easy to find.
Well, we cannot see. I mean, we don't integrate over a long time. We look at it, and so it's there.
We'd have to know which one. You'd have to use a little finder chart and carefully figure out which one it is. And artist representation, what that planet might look like, I don't know. One more shot, we have TESS in operation. Transiting Exoplanets Survey Satellite launched in April of 2018. As of February 2020, it's found 1,660 candidates. 38 are now confirmed, and there's 3 months left to the end of its original planned mission. But since it's operational, I'm sure they'll extend it and keep going.
What is the limiting factor? Is it budget, or is it fuel, or what is it? Or is it gyros again?
Yeah, I think it's just like the Mars rovers. They had planned missions of 6 months. It's like, if we can get all the observations we want in this time period, we count it a success. Everything else beyond that, it's overtime, yeah. So MIT, NASA, and Google actually work together on this. All right, so let's get to the intelligent life. What defines it? Well, what was Earth like 1,000 years ago? We certainly had an intelligent life here, but was it observable from a distance? Not really. I mean,
There were no emissions, basically.
yeah, smoke signals are not really going to be visible. Telegraph wasn't either. It wasn't until we started getting radio, television, radar, microwave transmissions that we really began to make an impact in the outside world. But more recently, we switched to cable TV, started putting stuff in fiber optic cables over the internet and using laser communication. We're becoming quiet again, and what we do have is much more resembling noise, because cell towers use spread spectrum technology, and there's so much stuff at almost the same frequency occurring all the time and serving local pools on Earth that, yeah, power's going down and becoming more focused. So yeah, it was like a century of a window of where we were sending out discrete, detectable signals. So radio now is about 114 light years out. 1906 was the first transmission. They played "Oh Holy Night" on Christmas Eve, and it was heard by ships at sea. TV is now 89 years old. With the 1931 New York City station that went on, the Olympics in 1936, that was featured in Contact with Heil Hitler coming back. Of course, SETI, the search for extraterrestrial intelligence, is working to find signals from other civilizations. One of the favorite places to observe is the water hole. The water hole is a 21 centimeter line of neutral hydrogen, and they first did a lot of the work on the Green Bank telescope. It collapsed in 1988 on a calm, cool, windless night. I guess the operator stepped out, looked around, went back in, set his coffee down, then everything vibrated a little bit, and that became that. So, but now it's that.
Metal fatigue.
Yeah, it was really, yeah. It probably would have taken him out if he'd been out there. So we've heard from the radio guys that funding has come and gone, and it's been touch and go and kind of scary, but it's still operational.
Hey, Dad,
Yes, sir?
is my battery using?
No, sir, not right now. Another telescope we use a lot is Arecibo. This also has continuing funding. It's a 305-meter radio telescope. Stay back over there, please. In Puerto Rico. The water hole is a relatively quiet zone in radio frequencies where natural processes out in, stay over there please, just a second. We're going to take a break in just a few minutes, okay, and then we can talk. SETI was first proposed as the LISTEN project in 1955. Early work again was at Green Bank. In 1963, the Big Ear project started. NASA funded Project Cyclops in 71 and then took the money away. In 77, the WOW signal happened. Here's a printout on paper, and the astronomer on duty saw that. What basically this is if there's really nothing but noise, it's blank on the paper printout. Numbers are a very minimal signal, and then when it runs out of numbers and goes into the letters, it's a very strong, discrete signal. And we have continued to look there.
But it didn't repeat.
It didn't repeat. We keep going back. Look, it's close to 2.5 degrees below 5th magnitude star Chi 1 Sagittarius.
So it was close to it could be noise from the black hole.
Yeah. Could be. I mean, was there a pointing error? Was it a spurious signal so strong that it bled over? Yeah. We don't know. And then who speaks for Earth is a question that we're still kind of talking about. I mean, whose White House lawn would they land on? Of course, abductees and like that think we've already been contacted, and it's all a done deal. But we have little or no agreement among scholars on, if they landed on one country, are they the ones that get the first say in communication, or can we do this to the UN and do it as a planet-wide thing? SETI Declaration of Principles forbids response until the question is resolved, but with that, who's going to follow it, right? So we did send out a signal in 1974 towards M13, about 25,000 light years away. This is the signal here. Translating it, it teaches the numbers 1 through 10 in this code here. Then it uses that to show the elements most important to life. Then the sugars and amino acids that make up us, the double helix of the DNA, the number of nucleotides in humans, the pairs, figure of a human, our height in the same numbering system, population of the Earth at that time, a diagram of our solar system which has Pluto, right, as a planet. That'll confuse the aliens. Oh wait, Pluto's not a planet. And the third one from the sun is tilted towards us, showing that we're there. There's the Arecibo itself and its size in that numbering system, I think in angstroms. So, do we want to be contacted?
Very much like the disk that was sent
to
Voyager.
I'm going to get to that actually. Turn it down a little bit down the volume. Stephen Hawking, before he passed away, famously came out and put the same warning out that if we call attention to ourselves, we just may be exterminated or invaded or taken for all of our resources. So, what should we do about that? And for the most part, our wargaming and science fiction, it turns out bad, except in E.T. and Close Encounters. So, for modern SETI, University of California, Berkeley.
If you could go back to the previous view.
Sure.
The third bullet. I mean, how can you expand us being here on Earth maybe 1 million years to go to billions of years?
That's true.
I mean, that is too much of an stretch, I think.
Well, one of the warnings in from some of the science fiction authors, that when you think about the technological singularity, get back behind the line, please. Technological singularity is where someplace decades out, artificial intelligence comes online, becomes universal general intelligence, and within hours, if not days, completely outstrips the intelligence of any human, and within days or weeks can outthink our entire civilization. And what would it want? What goals would it set? What would its values be when to it, our measly little morals and values were something that thought about millions of years of computational time back in the past. So the warning is, don't try to write beyond the singularity, that you won't get it right. And so, same thing, if you're going to talk about a very advanced civilization, can you really even guess? So.
And the temporal factor
exactly.
is dominating.
So yeah, we have search for extraterrestrial radio emissions from nearby developed intelligence populations, SERENDIP, and we've had multiple other versions going. SETI at Home, founded in 1999, uses distributed networks to create one of the most powerful computers on the planet, using people's, please stop stopping, Brandon. I'm correcting you a lot. This is being recorded, sir. You got to show that you can come someplace and be quiet. So over 6 million computers are working on it in 234 countries plus. Each PC gets a little bit of the data. The data is worked on multiple computers over time. At least 19 billion hours. By now it's probably much more because Moore's law is expanding things so much better, so much more rapidly. 769 teraflops. It was the second fastest supercomputer on the planet in 2008. Of course, now we have many petaflop computers out there. And the Allen Telescope Array, which is still kind of under construction, is contributing data to this as well. This is what the screensaver looks like. I'm running it on, yeah, I've been running this on all my computers since about '99. So I guess you would end up on late night talk shows if your computer discovers somebody. Here's the Allen Array, artist's conception of what it would look like when it's finished. It's up in Northern California. Here's the first dishes once they got installed. These are cheap, easy to install, and the more spread out they are, and the more there are of them, the more sensitive they get to signals. They can look in unison at one spot or pursue different goals at the same time. Funding ran out in 2011. Short-term funding was found in August 2011, and operations resumed in December of that year. And I think that's still producing data. Still.
Who is funding it nowadays? International Science Foundation, or?
I don't think so. I think it might be more private donations. It might. Just a second, we're going to be in a break in just a minute. So as of 2016, SETI Institute performs observations between 6 p.m. and 6 a.m. daily. It's managed by SRI International, which is formerly Stanford Research Institute. Future of SETI, there's other things we can look at than radio signals around 21 centimeters. Optical searches, if civilizations are using laser technology to send tremendous amounts of data around, we can look for laser flashes as they accidentally point our direction. There's a METI project trying to put together messages to extraterrestrial intelligences, and like that. So there's optical SETI at Lick Observatory. Frank Drake. That's Frank Drake. Yeah, he is the father of searching for extraterrestrial intelligence, and he is still alive, I think. Yeah, and so he certainly took a lot of scorn early on. Yeah, a lot of scorn early on, but it's now respectable science. We even have exobiology as a discipline now, taking a look at the extreme degrees that life can survive under.
I think that's where Emily, our degree is in.
Okay.
PhD was in astrobiology.
All right. So far, Experiment Lick has examined around 300 individual star systems, looking for laser signals. Of course, we got a slow message on the way out, and this is a gold record, because records will never go out of style. And aliens will certainly have it. There's a record player there and instructions on how to use it. Yeah, but they have a diagram on the back that talks about how to use it and figure the stars around our system so you could pinpoint where we've come from. I think they just put the CD out, right? Or you can now get the Sounds of Earth as a download from Apple, but it was a long time it wasn't available. It was very strange. I guess too much copyrighted stuff that they couldn't work all the rights out for. So both Voyager 1 and Voyager 2, not Voyager, to be confused with Voyager 5, which never happened, they're out. Voyager 1 is 106 plus astronomical units away. It's the most distant Earth-made object known until, I think, New Horizons. I think New Horizons has beat it now. Turn it down, buddy. All right, so let's talk about the Drake equation after a break. And so Frank Drake came up with this estimation tool that probably more than anything it has focused research more than producing an actual useful number of any kind. It's given different research avenues focus, a why to go after these things. So Kepler was trying to figure out the probability of stars that have planets, for instance, or the number of planets in the life zone or Goldilocks zone, or just getting the total number of stars in the galaxy anchored down more. Variations from trillion to 100 billion still exist out there. Pardon me. First cough, I think. So depending on the assumptions that you make throughout all these probabilities and numbers, we can get between 0.01, well, we have one civilization here, all the way up to 0.1 using some of the earlier numbers. In 2020, depending on the numbers you can plug in, you can go from between 1 and 15,785 with, on average, each civilization being about 28,000 years apart from a median number there. And there's more detailed ways to estimate it. When you take a look at this form of estimation, you take a look at probability of the nearest civilization and how far away it is from us, that's really far. I mean,
Still 2,000 light years.
right, all of human civilization is only twice that. So, another expression of this takes a look at things like a stellar filter, average number of planets in each planetary system, a planet filter, biological filter, and then what you do is you look at the age of the stars you're looking at, and you can apply this big correction thing to it, and it's just crazy. I mean,
This is only for our galaxy?
just for our galaxy, yeah. Because there's probably the only hope of picking up a signal be relatively close. And when you look at, everything may be right, you got a planet in the right place, right temperature, life arises. We've had many near planetary extinction events over time. So we've had major impacts of the red triangles going back 600 million years to the present. 600 million years is not the entire history at all. It's really recent geologically. And major eruptions that have altered the chemistry of the atmosphere and really changed the climate for a little while, are very frequent. 99.9% plus of all of these species that have ever existed are gone. It's from the first life to now. But in the universe now, how many planets might there be? Well, it might be close to 1 septillion stars in the universe, and which is surrounded by planets to support life. So if it's 5, you got 5 septillion planets, possibly, if that's the average. So how many civilizations might be out there? Granted, too loud. 10 in 1961, about 7 in the mid-2000s, or this estimation from 1 to 15, 16,000, depending on all the assumptions that you make. But the universe is a hostile place too, not just stuff happening to your planet, but there's regions where you have lots of ultraviolet light. It would sterilize planets in that area. You have supernova explosions and things like that occurring. But we're going to keep looking. We're going to look for Earth-like life, and hopefully we can be smart enough to look for non-Earth-like life. To quote Ellie Arroway in Contact, if it's just us, it seems like an awful waste of space. But again, there's people who think we've already been contacted, so we've got UFOs out there. One of the most famous is the 1947 Roswell event. The big question is how do they get here? I mean, the travel times between star systems is fantastic, just communication time.
Solve the speed of light problem.
Right. Do you have warp speed, wormholes?
Parallel universes.
Right, parallel universe, you sneak over from there. But then people with sort of X-Files-like conspiracy hunger say it's all been solved, they're here, but it's being hidden from us. But still, we have experimental flying objects that we make that look weird. But the Roswell event occurred July 8th, 1947, and the newspaper headline that got the whole thing started, the Air Force captures flying saucer on ranch in Roswell region. No details of flying disc are revealed. Roswell hardware man and wife report disc seen. A few days later, they retracted the story and came up with a weather balloon story. With modern digital technology, people have zoomed in on this and tried to enhance it. And they think they interpret all this, the victims of the wreck, in and on the disc, plus other phrases seemingly in the context of a crash vehicle recovery. So
it looks like a helium balloon kind of material, like Mylar or something.
Right.
He has in his hands.
But did we have anything like Mylar in the 40s? So,
I think we did.
yeah.
Yeah.
Looking at the geography of Roswell, so Roswell, New Mexico is the A, Alamogordo, New Mexico is location B, Ares, the wreckage is actually up here in C, and Albuquerque is up here in D. So the wreckage is consistent with the launch number 4 of what was called Project Mogul, found 75 miles northwest of Roswell. And we've done lots of other test things that have looked weird, like the Viking Mars heat shield test. That's pretty alien looking. The Viking space probe test was dropped with parachutes. Project High Dive was trying to see the effects of high altitude ejection systems for pilots and what would happen to their bodies. And these were mannequins or test dummies. But people are convinced that UFOs have occurred. We got pictures of V-shaped things with lights on them. We have the Phoenix light incident. I don't know if I have a slide of that, but yeah, no, I don't, except for that. One of my personal questions is that with the ubiquity of high resolution, now with iPhone 11, low light level cameras that can record like crazy, why aren't we getting an exponential increase in UFO footage, really good UFO footage out there? And we're not. I mean, we have not only...
It's almost like dropping off.
It's dropping off, right. We have incredible videoing capabilities, and we have a planetary-wide distribution network on YouTube and other video sites. It should go up, and it doesn't. It has not. So where are they with the aliens? There are 4 possibilities. There just are no galactic civilizations now. We may be the first. They exist, but they don't leave their home. SETI might find them. There is a galactic civilization, but it's deliberately avoiding us, like the Prime Directive in Star Trek. Or it's all an X-Files cover-up. The question is, can people really keep a secret this big for this long? They do discredit and make people who report UFOs sound goofy, and they kind of naturally do. So maybe it's a self-inoculating thing that civilization does, and just kind of laughing at people with outlandish claims. Probably.
A lot of the evidence came from the era when we still had to develop pictures in a bath.
Yes.
And I worked at a shipyard in high school as a summer job.
Mm-hmm.
And what we did is we took X-ray pictures and other pictures of wells in an oil drilling platform.
Okay.
And if the guys who were in the lab didn't feel they were treated well by their bosses, they would take some of the granular development media,
Okay.
they throw it in the bath and not let it dissolve all the way,
Okay.
and then put the development material in the film, and then make some scratches on it.
Oh,
And they could control what kind of scratches they did, so then it looked like a well was faulty.
Oh
And then
no.
we had to gouge it out again and rebuild it. So these guys could control it, and I wonder if some of the UFO evidence is from that era.
Mm-hmm.
To control what you get on the film.
Sure.
And it's
Yeah.
mostly black and white because it's night photography.
Mm-hmm.
So it looks like scratches would show up with the light.
Yeah. Absolutely. Or if you just put some little saucer-shaped shadow on there, then when you develop it, it flips. Yeah, absolutely. So getting between the stars, let's talk about the practicality of this. The Pioneer spacecraft, each light year would take 10,000 years of travel time. I think New Horizons is actually the fastest. Okay, Brandon, too loud. Shh. Starships, we have things like nuclear pulse propulsion that is proposed. You just kind of keep popping off small nuclear explosions in the back. You could get up to about 3% the speed of light. Fusion rockets, if you could develop this technology, you can get up to maybe 10% the speed of light, but you've got to take a lot of fuel with you, unless you get along the way. A ram jet would scoop up interstellar hydrogen in the front end, compress it, store it in these tanks, and then fuse it out the back.
UFO looks like that.
No, that's true. Antimatter rocket certainly could get you very far. It's a lot of energy release. Problem is,
You annihilate yourself.
you annihilate yourself. You can't store antimatter. In the entire history of humanity and science working with materials and subatomic particles, we still have not even created a paperclip worth of antimatter added up, which really ruins one of the Dan Brown plot lines where they're stealing antimatter. Another possibility, get you up to about a quarter the speed of light, is a light sail. You can even get a better kick from that if you get some giant energy sources on your home planet or moon and pump lasers out to it. You could tack around a star, very much like a sailboat does in the wind on the bay.
And we do that as gravity-assisted planets.
Mm-hmm.
Basically.
Daddy, I'm hungry.
Okay, we're almost done. You just wait a minute. But if we could get things like wormholes, then the universe is our oyster. We could pop through space and time and get someplace else. And I say space and time because, like we talked about when we were discussing the bulk model of the universe and the concept of now in, stay back there please. No, not right now. I'll stay behind the line. That when I'm walking a certain direction, then a galaxy, a quarter of the way across the universe, I am now, it's now, with my now, is way in the future. And if I walk away from that galaxy, its now is far in its past. And so if you were to open a wormhole and have any relative motion between the two throats or openings, you've got a time machine as well, which that can wreak havoc on causality and stuff like that. But what you need is negative energy or negative matter, and we don't know that that stuff exists at all. And another problem might be that as you begin to peek into another destination in the universe or some other universe, as soon as you begin to cross the threshold, you get completely baked out of existence by unbelievable amounts of energy. So it's tough. So what are we going to look for? We'd like to look for signs of life, like large amounts of free oxygen. Carbon dioxide is very stable, and we obviously have lots of planets in our solar system that have a dominant carbon dioxide atmosphere, even though life exhales it, and mammals do here. That's not a good signature, so you want things like that.
But on the other hand, if you think about neutrinos,
Mm-hmm.
they go through matter almost at the speed of light.
Stay back over there. Mm-hmm.
If you look at some of the neutrino detectors in mines
Mm-hmm.
deep,
Mm-hmm.
I mean, you see them go through the earth.
Right.
And how does that work?
I know. I say, just wait over there. We're almost. I know. Just sit back over there. Well, these are our movie representations of aliens. But if you just look at what's in the bottom of our own sea, that stuff is really hard to recognize as life to us. No, it looks really, But this is pre-alien life right there.
Yes.
So the concern is that we may not realize intelligent life or life when we first find it, and we may step on it. So we'll keep looking. All right, so wrapping up, if you want to be an astronomer, limited entry, a pretty small number of astronomers in the world, only about 20,000 astronomers and physicist jobs, about 1,700 of those are astronomers. Only about 11% of degree holders hold astronomy-related jobs in the end. Working conditions are university settings, sometimes mountaintop, but much less so with the...
It's mostly computer.
It's mostly computer work, operating everything remotely. And field work sometime if you're developing new equipment. Getting a job, you need good computer programming skills because you have to make the software that you need. High degree of math and physics skills, writing, public speaking. Average salaries, I just updated actually a couple months ago, 72 to 166,000, starting salary usually 58, median's about 106. Number of jobs about 20,600, which has grown 14% by 2020. So for education, you usually need a doctoral degree to get to the higher levels, but if you have a bachelor's and master's degree, you can get some applied research and development positions.
And that's when writing comes in. You got to write for your brains all the time.
Yep. So currently, this is where we're left with the unanswered questions of astronomy that we're going to have to cover in future things. So how does relativity and quantum mechanics work together? Do we have quantum gravity that we can figure out? String theory, does it hold water? How do black holes actually work? Does relativity really apply on all scales of energies in the universe? Or when you get to the extremes, do we need new or modified theories? Is the standard model quantum mechanics on the right track? What's gravity and why is it so weak? We do have the Higgs particle, so that one's crossed off. Is there an equation that unites all the forces? What's the true nature of space-time? Is some of that emergent or not? What's dark matter and dark energy? What's the full structure of our universe? Are there parallel dimensions, other structure like that? How many places in our solar system may have life, and how many planets in our galaxy may have that, and how many may have technologically advanced life? And what drives changes in our sun? What's its future going to be? We're starting to get a hold of what gamma ray bursts are, but we've got a ways to go. Brandon, too loud. When do the first stars turn on? How does dark matter relate to the formation of large structures in the universe? Why are most stars in the main sequence? Okay, Brandon, you're being too noisy, buddy. Okay, leave me the car. Okay. How the universe really start, and what will the ultimate end be, and more. So there's a lot of work to do out there. Ultimately, we want to know, who are we? Can we get out into the universe and explore? Are there other energy sources that we can tap into? And we just like to explore and adventure. And eventually our sun will die. And so if we want to survive, we're going to have to move away or get our Earth moved out or move it. And if we do discover alien life, how do we share ideas with it? So this is not the end. We may have a few billion years to 100 billion years before the universe itself is done. So there's a lot of fun we can do in that time.
Of course, technology progresses, so if there still is a civilization a billion years from now, then the technology will be a billion years further advanced, we assume.
And look what we've done in a century.
Back to the Dark Ages.
Right. This is.
I'm done.
Yep, we're done.
We're done.
So thank you very much.